Okay, this video is going to cover concentration of ions, chapter 9.5, a big jump in, I guess, the location in our textbook, but I believe it's going to be very much related. Please note, I took the liberty to take out the homework section for 8.7, so there it is. Please make sure you try it. The reason why I decided to jump, or rather the department as a whole decided to jump to concentration of ions, because the train of thought sort of segues very nicely to it. It also is a very light stoichiometric calculation when it comes to solutions. Let me give you an example. Ionic compounds. When I have a ionic compound, and let's say like calcium chloride, if you check the solubility table, you will know that this ionic compound will in fact dissociate or dissolve into its ionic parts, okay? Ion components. And chlorine would be 1-, but as you can see, I have two of them. Essentially, calcium chloride will dissociate to calcium and chloride in a 1:2 ratio. And as you can see, I am going to draw your attention to the coefficients. And in stoichiometry, what do coefficients help us with? Mole ratios. That's right. Let me give you a visual as a better representation. Let's pretend I have a single calcium chloride ionic compound, okay, a molecule or whatever. Given time, allowing the water to do its dissociative powers, you will get a single calcium chloride, but I will have two chloride ions. That's essentially it. And because this is in fact true, we need to make sure that we are not, we are using, mole ratios. What do I mean by that? If I have a single mole of calcium chloride, that will turn into a single mole of calcium and 2 moles of chloride ions. Better yet, let's just to keep it simple, if I have 1 liter of this, 1 liter of the solution, in essence, what is the concentration? 1 mole per liter of calcium chloride ions is equal to 1 mole per liter of calcium ions and 2 moles per liter of chloride ions. Right? The concentration of CaCl2 might be 1 mole. But if I asked you for the concentration of the calcium ion and the concentration of the chloride ion, they are different. And that's what you have to watch out for. Okay? Let's keep it simple and try some simple examples together. Here is the first one. I'm actually going to go straight into page 448 and do with you the sample problem. The reason I want to do the sample problem, actually I need more space. The reason I want to do the sample problem is because the textbook does it a certain way, and I think it's a bit convoluted. I want to show you how you can do concentration of ion stoichiometric calculations the same way we did before when we created a chart with a chemical equation. All right, so if you want to pause the video and sort of copy down the homework, you can. I'm going to clear all this space and write out the question for you in 3, 2, 1. Here we go. Here's my question. All right, so sample problem 1 on page 448. Sample problem 1. It says this: a technician dissolves 17.1 grams of aluminum sulfate, Al2SO43, to prepare 250.0 milliliters of solution. What are the amount concentrations of aluminum ions and sulfate ions in the solution? While we do this, some of you might ask, why the heck do we care about ions separately? You'll see later. Just walk through with me, okay? So here's what's happening. I'm going to write out the chemical equation for this. I am taking aluminum sulfate and allowing it to dissociate into its ions. Okay, so that's aqueous, and this is aqueous in a 2:3 ratio. Do you remember how I asked you to always do little m, molar mass, and moles? Well, moles, if you remember, directly links us to C times V, right? C is equal to N over V, which means N is equal to C times V. All right, let me show you why. 17.1 grams is right here. I want the concentration of these two, right? So taking this, let me use a highlighter with a different color. I'm going to take the number of grams, turn it into the number of moles. And because I already know I am preparing 250 milliliters of a solution, I know this is going to be 0.250, which means using the number of moles and volume, I can calculate the concentration. Using this concentration, I can go straight into mole ratios. But you might already think, whoa, 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 that's a little bit different. So let's backtrack. Forget all that. Forget all that. Let's pretend you found the number of moles. If you found the number of moles by using mole ratios, you already know the number of moles of aluminum ions and the number of moles of sulfate ions. The clue from the question will tell you how many liters of solution I have, which means with the number of moles and the volume, you can find the concentration of both. All right, let me play that out for you in case I've lost you already. Let's take a look. I'm going to first take the number of grams of aluminum sulfate and calculate the number of moles of aluminum sulfate. Okay, the mass is 17.1 grams. The molar mass is going to be 2 times aluminum, 2 times 26.98 plus 3 times sulfur plus 12 times oxygen. That is going to be 342.17 grams per mole. So the number of moles will be yeah, I got that. 17.1 divided by the answer, 0.049975 rounded. It's going to be 0.0500 moles. Well, that's nice of the question to give us such a nice round number. So 0.0500 moles is how many moles we're dealing with, if that's the case. The textbook does something a little bit funky. I think it's just so much more organized to just create a chart and figure out how many moles we have. The number of moles of aluminum ion is equal to the number of moles of, to the number of moles of aluminum sulfate is going to equal 1 to 2. Okay, so if I have 0.0500 moles of this, what would that be? 2x is equal to 0.0500, x is equal to 0.025. You can hate me later. Love me now, okay? Please. That is equal to I don't know what this is, but 0.0500. X is equal to 0.100 moles. 0.100 moles. And in the same way, let's pretend I don't know how to do this in my head. Na2SO4 3. The mole ratio is 3:1 equals X over 0.0500. X is equal to 0.150 moles. 0.150 moles. Because I know the final volume, basically 0.250 liters, 0.250 liters, the concentration of the aluminum ion is going to be the number of moles divided by the volume, which is 0.400 moles per liter, and the concentration of sulfate is going to be 0.150 divided by 0.25, which is going to be 0.600 moles per liter. Okay, I went a little fast there, but again, I'm taking for granted your knowledge of mole ratios, which is something that you should have been able to do already. Your knowledge of using C equals N over V, which is something that you should have been able to do already. The only new thing is the fact that a chemical equation, I guess, could be written for dissociation, right? And this you should already know. I'm simply adding this to the pile so that you use the same stoichiometry format that we've been using before, all right? Let's try a different one. I know in the homework I assigned to you numbers 1 to 3 on page 448. I am going to do number 3 with you. And clearing this sheet in 3, 2, 1. Here we go. Text. On page 448, it says, number 3, it says, calculate the mass of sodium phosphate required to prepare 1.75 liters of solution in which the sodium ion concentration is 0.25 moles per liter. Textbook says the answer is 24 grams. Let's confirm. All right. Let's see. This time I'm not even going to create an equation. I'm looking for the mass of sodium phosphate. If I want to prepare 1.75 liters of a solution in which sodium ion concentration is equal to 0.25 moles per liter. Maybe I do need to write an equation just to keep ourselves from getting confused. So it seems like being a dilution, I am going to simply have Na3PO4 dissociating into 3 ions of sodium, AQ, plus 1 ion of phosphate, AQ. What mass do I need if I am going to have a concentration of 0.25 molar and I want a volume of 1.75 liters? Okay, here's my pathway. I'm going to use C and V to calculate how many moles I need. Once I calculate the number of moles, we can use mole ratios to get to the column of interest. If I have the number of moles for the compound for the column of interest, I can use the information for moles to calculate the mass. You see how the number of moles, the mole ratio, is going to help us out in any given situation. This is stoichiometry for solutions, okay? You want that middle, I guess, row filled in so that you can navigate around an equation. So let's do it, okay? The number of moles of sodium ion is equal to C times V, which is 0.25 molar times 1.75. How many moles do I have inside the solution? 0.4375. So that means 0.4375 sig figs for 4 moles. All right, let's do it. Mole ratio, the number of moles of what I want to the number of moles that I have is equal to 1 to 3. 1 to 3. If that's the case, how many moles of sodium phosphate do I actually need? If I have 0.44 here, 3x is equal to 0.44, x is equal to 0.146 repeating, which is basically 0.15 moles. This is 0.15 moles. All right, let's do the last bit. If the number of moles of the sodium phosphate compound is 0.15, the molar mass I can find right away, 3 times sodium plus 1 phosphate. I keep forgetting phosphate. I should really have this memorized by now. I fail you as a chemistry teacher, my people. 30.97 plus 4 times oxygen. .94 grams per mole. That means the mass is going to be 24.591, which is approximately, because of sig figs, 25 grams. Therefore, I need 25 grams of sodium phosphate to create the solution that I need. And that's it. I found a very challenging question proposed by one of Northern's other chemistry teachers, the original Mr. Kim, the OG. And so I'm going to actually propose that for you. And then later on, I will put up an answer video that he has created for this exact question. So I'm going to clear the screen in 3, 2, 1. And the question that he asked his class is, let's see, if he has 125 milliliters of, let's do this, 5 milliliters of 0.400 aluminum 2 sulfate 3 is added to 225 milliliters of 0.200 molar MgSO4. Find the concentration of all ions in the mixture. So earlier in the video, I asked, why would you ever want to calculate concentrations of ions? And the idea is this: sometimes the same compound or the same ion can come from 2 different sources. Sulfate is coming, the number of moles of sulfate is coming from 2 different sources. Aluminum, we calculate normally. And magnesium, we can also calculate normally. It's that sulfate that can be confusing. Here's a hint. You're going to essentially, you have some amount of aluminum sulfate with a whole bunch of stuff inside it. You're going to have to calculate how many moles of sulfate is here, okay? And then you are going to be mixing it with a larger volume, right, with MgSO4. And so you want to find out how many sulfates are actually here, because once you mix it, you'll have this many moles of sulfate, right? And then once you find the total, you sort of want to calculate the concentration of the sulfate. Do that for all the ions. See what you can do, okay? And stay tuned for the video solution, giving you the solution for this question. Your best, and without, you thought I would forget, you might want to refer back to the beginning of this video, but this is another set of questions that you can do as practice. Your very best. Hope to see you soon, but yeah, just do what you can. Stay safe.